Hello everyone, so today we are going to start with glycolysis. So let's start. So give the heading glycolysis. Glycolysis. Okay, so glycolysis starts with the glucose. Okay, so let's write here glucose. Okay, so the glucose gets converted to glucose 6 phosphate. Okay, from glucose 6 phosphate it is getting converted to fructose. If you see TOAC, fructose 6 phosphate. Okay, now from fructose 6 phosphate it is getting converted to fructose 1,6 bisphosphate. Done. From 1,6 bisphosphate it is getting converted to two parts. One is your di, or you can say dihydroxy acetone phosphate. This is called DHAP, and another one is called, from this only another one is being formed, which is called the, you can say, the 3-phosphoglycerate, GLYCERAT. Okay, I'm not sorry, it is not glycerate, it is glyceraldehyde. Glyceraldehyde. Done. This is also called PGAL. Okay, from 3-phosphoglyceraldehyde it is getting converted to 1,3-biphosphoglycerate. Okay, so let's write here, it is converted to 1,3-biphosphoglycerate. I'm sorry, GLYCERAT. Okay, now from 1,3-bisphosphoglycerate it is getting converted to a 3-carbon molecule, which is called 3-phosphoglycerate. Okay, let's write a bit down, 3-phosphoglycerate. Okay, now from here it is getting converted to 2-carbon molecule, which is the 2-phosphoglycerate. Clear? Now from this 2-phosphoglycerate it is getting converted to your phosphenol pyruvate. So let's write here phosphenol pyruvate. Okay, now from phosphenol pyruvate it is getting converted to pyruvate. Okay, so I'm writing over here pyruvate. Now this was the last. Okay, now let's number the processes. Okay, so with another ring let's number the processes. So this is number 1, this is 2, this is 3, this is 4, this entire 2 and 3 is 5, so I will write 5 2 times, 5. Okay, and 6 over here, here is 7, this is 8, this is 9, and this is 10. So the entire glycolysis is a process of 10 steps. Okay, now I missed out a thing while writing. Now these two things, the 3-phosphoglyceraldehyde and the dihydroxyacetone phosphate, are isomers. Okay, so you can give this symbol and indicate that this is an isomer. Okay, so the both can interconvert. Okay, now I will write about the enzymes now. what are the enzymes which are catalyzing the processes. Okay, so let's take another ink and write the enzymes. So glucose is getting converted to glucose 6 phosphate with the help of an enzyme called hexokinase. So let's write here hexokinase. Okay, also since a phosphate is getting added over here, so a ATP will give one phosphate over here and will get converted to ATP. So this is energy investment where ATP is supplied. Okay, so we will write this way: ATP is getting supplied over here. Let's make it a bit proper. So ATP, it is getting supplied and getting converted to ADP. We all know ADP is adenosine diphosphate. Okay, and one phosphate is getting added over here, right? Now this glucose 6 phosphate is getting converted to the fructose 6 phosphate with the help of an enzyme which is called phosphoglucoisomerase. This is phosphoglucoisomerase. Why isomerase? Because you have to know that fructose and glucose are isomers. Okay, now this fructose 6 phosphate is getting converted to fructose 1,6 bisphosphate with the help of phosphofructokinase. Okay, so let's write here phosphofructokinase. Now see, here another phosphate is getting added, so it is becoming biphosphate. So similarly, like we did over here, we will do again that same thing. So ATP will get converted to ADP. This is also an energy investment, right? Now see, this 1,6 bisphosphoglycerate is getting converted to both of this with the help of an enzyme which is called the aldolase. Okay, so let's write over here aldolase. Okay, and here since this process is reversible, so you can write the enzyme which is called the isomerase, which helps in the interconversion between the two isomers. Okay, so let's write here isomerase. Okay, now this 3-phosphoglyceraldehyde, it is getting converted to 1,3 biphosphoglycerate with the help of it is called the phosphoglucokinase. So let's write over here, phosphoglycerokinase. Okay, so let's write over here, it is called the, I'm sorry, this will be the triose dehydrogenase. Okay, now see here, this 3-phosphoglyceraldehyde, it is getting converted to 1,3-biphosphoglycerate. Now in this process, okay, this is the reduction, or you can say the redox process. Now here your NADH will be formed. So the NAD plus D plus will get converted to NADH, because this is a redox reaction and D plus is getting one hydrogen and one electron and getting converted to NADH plus. Okay, now this 1,3 biphosphoglycerate is getting converted to 3-phosphoglycerate with the help of an enzyme which is called phosphoglycerokinase. Okay, so where should we write? Okay, let's write here phosphoglycerokinase. Okay, now this 3-phosphoglycerate is getting converted to 2-phosphoglycerate with the help of an enzyme called phosphoglyceromutase. Okay, so this is phosphoglyceromutase, right? Now at last the 2-phosphoglycerate is getting converted to phosphoryl pyruvate with the help of an important enzyme which is called the enolase. Okay, this is enolase. Okay, now at last, the last enzyme which is converting the phosphoryl pyruvate to your pyruvate is called the pyruvate kinase. Okay, so let's write over here, this is called the pyruvate kinase. Pyruvate kinase. Okay, so this was the steps of your glycolysis. You have to remember that glycolysis is an anaerobic respiration because there is no involvement of oxygen in any way, and it occurs in cytoplasm. Okay, so let's write here anaerobic and in cytoplasm. Okay, it is an anaerobic process and occurs in your cytoplasm. So this was all about the process of glycolysis. Hope you liked the video. Thank you for watching.